welcome you all on this wonderful platform that is BYJU'S exam prep. So guys, please tell me, am I properly audible and visible to all of you or not? So this is one more session from the qualified series from the topic engineering mathematics and matrix algebra. And guys, in this session particularly we are going to talk about the rank of a matrix. That was the pending part from the matrix what we were going through. So today we are going to deal with the topic that is rank of a matrix. Okay, so we will be talking today about rank of a matrix. And guys, after that we will left with one more session on matrices and then we will go for some other topic. Okay, so guys, we are starting with this, and this is going to be useful for BARC examination, for GATE examination, ESE examination, because in all these exam mathematics is coming. So guys, this is some detail about me, and this is the Telegram channel Mechanical by Dheeraj Sardana. So you can join the Telegram channel to get the PDF of the session, the handwritten notes and all. So please tell me guys, am I properly audible? Shall we start the session now? Yes, please tell me. Let me check whether the voice is coming or not. Yes. Fine guys. So we are starting now. So guys, this is about the Mega Mock Challenge. As you know, Mega Mock tests are going on at BYJU'S Exam Prep app. 2 tests are already completed. The third test would be live from 11th November to 18th of November. And guys, once again, this time the syllabus will be manufacturing, material science, industrial engineering and IC engine. So you know, they are the part syllabus tests are going on. Yes. Pratham, yes. So we are moving further guys. So guys, this is the next heading, because in the last class we have discussed about symmetric and skew symmetric matrix. Now we will be talking about the orthogonal matrix. So my dear, whenever we are talking about orthogonal matrix, it is once again a square matrix, and the condition for a matrix to be orthogonal is A transpose is equals to A inverse, or you can say A transpose and A inverse would be equal, and A into A transpose will be identity matrix. And guys, if you are having a matrix like this, A1, A2, B1, B2, this is a 2 cross 2 matrix. If this matrix is orthogonal, then my dear, A1 square plus A2 square will be equals to 1. B1 square plus B2 square will be equals to 1. And A1 B1 plus A2 B2, that will be equals to 0. So guys, this is also the condition which must be satisfied if the matrix is going to be orthogonal, and we would be using them while solving the numericals. Okay, so like I have a question for you on this, whatever I have told you the property. This is a question where we have a matrix M, and they have given you 3 by 5, 4 by 5, X and 3 by 5 are the elements, and they are saying if transpose of the matrix M is equals to the inverse, it means it is orthogonal matrix. Then calculate the value of X. So guys, will you try and apply the same property which I told you? So what I have told you is, if the matrix is A1, A2, B1, B2, then my dear, I told you that A1 square plus A2 square is equals to 1. Then B1 square plus B2 square is equals to 1. Then A1 B1 plus A2 B2 is equals to 0. So guys, you just need to apply these 3 equations and then you will be getting the value of X. Okay, will you try this? Or yes, you have these equation in front of you, you can apply this and then you can get the answer. So guys, these are the 3 equations which would be satisfied for the orthogonal matrices. Okay, after that we are going to start the rank. Only this heading was left in the last class. So when we are talking about this, my dear, first of all, we will be talking about this first equation. So A1 square plus A2 square is equals to 1 means 3 by 5 ka square plus 4 by 5 ka square is equals to 1. That is not useful equation, I am just telling you. Then my dear, this you can use X ka square plus 3 by 5 ka square, that is equals to 1. From here you would be getting X is equals to plus minus 4 by 5. So my dear, we have 2 possibilities for X. One can be plus 4 by 5, other can be minus 4 by 5. Then my dear, we have one more property, A1 B1 A2 B2. A1 B1 means 3 by 5X. Then plus A2 B2 is 4 by 5 into 3 by 5. It is 12 by 25. So my dear, if it is 0, you will be getting the value of x as minus 4 by 5. So from here you can comment that ki x will be not plus 4 by 5 but minus 4 by 5. So this is how you would be calculating the value. Yes, Satyabrata Das, very good. You have done it correctly. So guys, this is the story for 2 by 2 matrix. Similarly, sometimes they would be giving you the 3 by 3 matrix also. So if they give you 3 by 3 matrix like A1, A2, A3, and then B1, B2, B3, and then C1, C2, C3, then my dear, once again you will say if it is orthogonal matrix, then A1 square plus A2 square plus A3 square will be equals to 1, and B1 square plus B2 square plus B3 square will be 1, and C1 square plus C2 square plus C3 square will be 1, and likewise A1 B1 plus A2 B2 plus A3 B3 will be equals to 0. Similarly, B1 C1 plus B2 C2 plus B3 C3 will be equals to 0. So we would be using these equation to find out the unknown value whenever the question will be coming for stating that it is an orthogonal matrix. Okay, so these are the properties, these are the equations we are going to use, and obviously you can write with the third one also, A1 C1 plus A2 C2 plus A3 C3 is equals to 0. So this is about the orthogonal matrix. Then my dear, we are going to move further, and the next heading for us is the rank of a matrix. But my dear, before we go to the rank of the matrix, because rank of matrix is a big topic, and it is also going to help us when we will be going for the system of equation. There we will see linear dependent, linearly independent. So before going to that, we are going to once again rewatch some basic definitions which would be used to define the rank of a matrix. Like if I talk the first thing, elementary transformation. So you have seen, I taught you at the time of determinants that we are having some row elementary transformations and some column elementary transformations. What are those? Like you can see the elementary transformations of row. Whenever you are going to change a row, Ri is becoming Rj. Whenever you are going to do Ri is, whenever you are going to say like you are interchanging two rows, Ri Rj. Or you are going to say operating Ri as k times of Ri. You are going to multiply it with a constant. Or you are going to operate it as Ri plus k times of Rj. When you are doing these kind of things, they are said to be elementary row operation. So when you are going to perform this, then my dear, you know that determinant and matrices. You know, whenever you are interchanging two rows, then my dear, whenever you are interchanging two rows, you know that determinant will change, matrix will change. Whenever we are going to do this operation, obviously determinant will change, matrix will change. Whenever you are going to do this operation, matrix will change, determinant will change. But my dear, why we are looking at these things? Rank do not change. Rank do not change after elementary transformation. Papa Ghoda, actually, as there are two classes clashing, one is at 8 p.m, other is at 10:30 p.m. So keeping that in mind, that production class is rescheduled to tomorrow 11:15. Okay, because otherwise two consecutive classes would be there. So that is why that class is rescheduled to the tomorrow 11:15 p.m. So production will be there tomorrow 11:15. So you enjoy mathematics right now. Rank of a matrix we are going to study. Okay, so production will be tomorrow, and after that I will share you the schedule of the complete week. Okay, before the Pavli. So guys, when we are talking about the elementary transformation, these are happening in column also. For column also you can have a interchanging of a column. For column also you can have a multiplication to the column. Ci is k times Ci. Then here also you can operate Ci operating Ci plus k times of Cj. Means adding some column with some multiplication constant. So whenever you will do this, obviously matrix and determinant are going to change. Okay, are going to change. So matrix and determinants are going to change by the elementary transformations. But my dear, rank of the matrix do not change. That's why while finding the rank, we would be going for the elementary transformations. That's why I told you this thing. Then my dear, I would also like to tell you, when we are going for elementary transformation, let us say we have a matrix B which is obtained by going for the elementary transformation on A. Then A is not equals to B. As I said, matrix will not be equal, but we will say that, we will be saying that they may not be equal, but they are equivalent. So if you are going for elementary transformation, the matrices are changes, but we are going to call them as equivalent matrix. So then we will be saying that A and B are equivalent to each other. Okay, so that is an important point. Now my dear, as I already said, when you are going for elementary transformation, the rank of the matrix is not going to change. So now we are reaching to slowly the definition of rank, my dear. Then my dear, we have also discussed once about the submatrix. Like if I am giving you a matrix like this, let us say I am having a matrix A1, A2, A3, or let me take the values in the form of numbers, because that is helping us more to understand. Like let us say 2, 3, 5, 1, 2, 4, 7, 8, 9. Okay, this is a square matrix. Okay, we can have this a square or rectangular matrix. Let us say this is a square matrix. So when we are talking about the submatrix, these are those all set of matrix which we are obtaining by deleting some of the rows or some of the columns of a matrix. Like my dear, if you are going to delete any row or any column, let us say you are deleting this, then you would be having a matrix like this: 2, 3, 1, 2, 7, 8. So this is a submatrix. You can also delete one more row or one more column. You will be getting one matrix as 2, 1, 7. My dear, even you can delete now these two rows as well. You would be getting a matrix with the number 2. So my dear, you can get these number of matrix by deleting any row or any column of the matrix. This is defined as the submatrix. Now my dear, this submatrix, you can have rectangular and square both. But when we are talking about the square submatrix, it is that for which rows and column numbers are equal. Like if you see this 2, 3, 5, 1, 2, 4, 7, 8, 9. So my dear, if you are going to delete this row and this column, you would be getting 2, 3, 1, 2. You would be getting 2, 3, 1, 2. 2, 3, 1, 2. Then it is said to be the square submatrix. It is said to be the square submatrix. Okay, so this is how we are going to have the submatrices. Now we are moving to the minors, and slowly we are going to define the rank of a matrix. Okay, so my dear, whenever we are talking about the square submatrix, I would also like to tell you, like if we are having a matrix like this, let us say 1, 2, 3, 4, 5, 6, 7, 8, 1, 3, 5, 9. If you see this matrix, this is having 3 rows and 4 columns. Then my dear, if I ask you, you are going to find out a square submatrix. Then my dear, the maximum order submatrix, which is a square, you would be getting only 3 cross 3. Because 4 cross 4 is not possible. So 3 cross 3 is going to be the maximum order square submatrix possible. So if someone is asking what is the maximum square submatrix is possible, if the order is m cross n, then my dear, you will take any number minimum, like minimum of m and n. Minimum of m and n. So that is, my dear, about the square submatrix I would like to tell you. Okay, so now we are moving further, my dear, about the minor. Minor, whenever we are talking about, it is the determinant of square submatrix. So whatever the square submatrix we have seen, if we take the determinant of that, you know that from one matrix you can have a large, means number of submatrices are possible. A number of square submatrices are possible. And we can take the determinant of theirs. So my dear, if you would be taking the determinant of a square submatrix, we call it as a minor. Minors are always defined in terms of their corresponding submatrix order. Like you will say minor of order 2, minor of order 3, minor of order 1, like that. Okay, and my dear, there is a formula from which you can get a question in engineering services HPCL type of exam. The number of square submatrix of order R in a matrix of order m cross n, it is going to be MCR into NCR. Okay, so this can be the question in HPCL exam, engineering services exam. So this type of exam can ask you the formula also. So be ready for all such type of things, as I already told you. Then my dear, we are going for the definition of rank of a matrix. We are going to talk about the definition of rank of a matrix. So my dear, when we will be talking about the rank of a matrix, let us say we are going to have a matrix which is A1, A2, A3, B1, B2, B3, C1, C2, C3. So this is the matrix. And my dear, this is a 3 cross 3 matrix. So my dear, as it is a square matrix, first of all, I would be asking you, tell me the maximum possible order of a square submatrix which you can get from that. You would be saying sir 3 cross 3 because it is a square matrix already. So the maximum order square submatrix will be 3 cross 3. So my dear, you would be checking the determinant of this. So you would be checking the determinant of this matrix. And my dear, if the determinant of this matrix is coming out to be non-zero, then you will say the rank of A is going to be 3. The rank of A is going to be 3. But by chance, if you are going to get the determinant of A is to be 0, then it is for sure that rank of A is going to be less than 3. Rank of A is going to be less than 3. Then what you will be doing? Then my dear, you would be checking the 2 cross 2 submatrices. Like you can check 2 cross 2 submatrices. This is one of them. A1, A2, B1, B2. You can also check one of them is also A2, B2, A3, B3. So there are many possibilities are there. So my dear, you can check A1, A2, B1, B2. Okay, you can check some other one like A2, A3, B2, B3. You know that you just need to delete one row and one column or any rows of any column to get the submatrices. So you can check 2 cross 2, many submatrices are possible. If any one of them is going to be non-zero, yes, Vinay, if any one of them is going to be non-zero, we would be saying the rank of that matrix is 2. Okay. So the point is what we need to do. We need to start with the highest order square submatrix and we will be checking the rank of that matrix. If the rank is coming, if the rank is coming out to be, if the determinant of that highest order is coming out to be non-zero, that is the rank. If determinant is coming out to be 0, we will go for one order less. And here also, if you will find all the determinants are coming 0, then we would be saying, okay, then rank of the matrix is even not 2, it is going to be less than 2. So my dear, then we will be checking the 1 cross 1 square submatrices. Okay, so that is how we are going to find out the rank of matrix. And in the upcoming classes, when you will be studying the vectors, and also vectors means matrix vectors, when we will study eigenvalue, eigenvector and system of equation, then you will get to know what is the meaning of the rank actually physically. Right now we are just looking at how to get the rank. So my dear, when we are talking about this, so the definition says if all the minors of order r plus 1, if all the minors of order r plus 1 are 0, then at least one minor of order r is non-zero, then the rank of the matrix is r. That's what I said. This is a 3 cross 3 matrix. If you find 3 cross 3 determinant is 0, it means the rank is not 3. And at least one determinant of 2 cross 2 is non-zero, the rank is 2. At least one. Okay. So my dear, this is how we will be checking the rank. This is the hit and trial method to check the rank. Like if you see this matrix. Now my dear, if you are checking this matrix, this is not a square matrix. This is a rectangular matrix. Here 4 rows and 3 columns. If I ask you, what is the maximum order of submatrix you can get from this? From this, what is the maximum order submatrix you can get? What is the maximum order submatrix you can get from here? Yes, tell me. What is the maximum order submatrix you can get? Maximum order submatrix. So you can see it is 4 cross 3. I already told you the maximum order submatrix which is possible here is going to be minimum of 4 and 3. So what will be your answer? Obviously the minimum of 4 and 3 is going to be 3. So you would be saying that 3 cross 3. Okay. So my dear, you would be checking the 3 cross 3, the 3 cross 3, the 3 cross 3, 3 cross 3 minus, okay, or you can say 3 cross 3 square submatrices, and you will check their determinant, And if you will get all of them are 0, then you will be checking for 2 cross 2. If they are also coming all are 0, then you will be checking for 1 cross 1. So what I want to tell here, are we going to do this task all the time? The answer is no. I will be telling you the techniques by which we are going to solve them. But just for the definition, I have defined it like that. So my dear, next we are going to move further. So my dear, if you have this, like let us say this is the matrix A. Just by looking at this, you can see as all the elements of this row are 0. When you will be finding out the determinant of A, you are going to get 0. It means the rank is going to be less than 3. That is for sure. Then I would be checking the 2 cross 2 determinants or 2 cross 2 square sub matrix. Let us say this matrix I am checking. So if you find out the determinant of that, it is 1 cross 4 minus 3 cross 2. So 1 cross 4 minus 3 cross 2. So you would be getting the answer to be minus 2. So as it is not equals to 0, it means the rank of A is going to be 2. So this is the example I have taken, my dear. Now we are going for the properties. Now we are going for the properties of the rank of a matrix. Are we ready for that? Shall we start, guys? Are we ready for that? Shall we start, guys? So we are going for the properties, but properties we are going to learn with the help of questions. Okay. So my dear, when we are talking about these types of matrix, first of all, I told you, if it is a square matrix, you will be starting with 4 cross 4 determinants. If all 4 cross 4 determinants are coming 0, okay, then you will be go for 3 cross 3. If they are also coming 0, then you will be going for 2 cross 2. If they are also going to be 0, then you will be going for 1 cross 1. Okay. And if anywhere you find non-zero, that is the rank. Like if 4 cross 4 is coming out to be non-zero, if it is coming out to be non-zero, then rank is 4. If my dear 4 cross 4, if 4 cross 4 is coming out to be 0 and you are checking 3 cross 3 and you are getting non-zero, then the rank of A is going to be 3 and so on. So this is the procedure, which is a rough procedure. Okay, real procedure is somehow different. Real means what we are going to follow. Otherwise, this is the rough way to see that. Okay. ISRO exam kab hoga? Animal lover, we cannot say about that. But I feel now it will be delayed. So maybe the chances are that they will announce it in January, February or after GATE also, because till date there is no announcement. Okay. But I feel that first civil was there, then mechanical notification came. So I feel now whenever one will be starting, then they will be in the continuation. So we cannot predict exactly, but the chances are now they are delayed. So maybe in January you will see the exam. Okay, guys. So now we are going to have the next case. Okay. This is a matrix. This is a matrix. Satyabrat, you are asking or telling me, I didn't get your point. Are you telling about the previous case or are you telling about the upcoming case? This is the matrix I have given. Now we will be looking at the properties by the questions. Whatever I have done, this question is okay, na? This question is okay. This question is okay. If you are talking about diagonal 0, then we are going to talk about that. Don't worry. These are the properties we are going to discuss now. So my dear, this is a row matrix. This is a row matrix. Row matrix or column matrix? Yes, row matrix or column matrix? This is row matrix or column matrix? What you will call it? Arey bhai, row matrix or column matrix? What it is? It is row matrix or column matrix? I taught you that. Row matrix or column matrix? Yes. It is row matrix or column matrix? It is column matrix. Okay. So my dear, if you see this, you know that this is the order 1 cross 3. So you tell me, what is the minimum of 1 and 3? What is the minimum of 1 and 3? Minimum of 1 and 3 is 1. So my dear, the maximum order of a square submatrix you can have would be 1. So because of that, here the rank of matrix A, when you are going to find out, you will see 1 cross 1 matrix can be this element. So this is non-zero element. So that is why the rank of A is going to be 1. I would like to say, my dear, always the rank of this row matrix, whenever we are talking about, it would be either 1 or 0. When it can be 0? Because my dear, you can also have this matrix where all the elements are 0. Then my dear, you know the minimum of 1 and 3 is still 1. So when you would be finding out the rank of a matrix, once again it would be coming out to be what? You will say that 1 can be the maximum value of order of square submatrix. So if you will take any of the element, they all are 0. So my dear, when you are going to have this kind of null matrix, then we call it the rank is 0. But generally 0, whenever we are writing, we also have a meaning of undefined. Generally the rank of null matrix is undefined. So that is why whenever you have this condition, you can say for a row matrix or a column matrix, you would be having the rank, either 1 or 0. These are the two possibilities. Okay. And the same we can see with the row matrix as well. Row matrix, column matrix have similar properties. If you see this, once again 3 cross 1 minimum is 1. So that is why you can have the square submatrix of order 1 cross 1. 1, 2 or 3. All are non-zero. If even any one is non-zero, you would be saying the rank of this matrix A is going to be 1. Similarly, if you are going to have 0, 0, 0, you would be saying the rank of A is either 0 or you will call it as undefined. Okay. Clear for everyone? Please tell me that. Yes. Then my dear, I would also like to tell you here that there is a scholarship test. I feel it is completed today. It is today 5th of November. And there is a workshop on 8th of November that will be taken by Joshit Singh sir. And guys, this is having heading of roadmap to secure AIR 100 in gate 25. So if you have any known one who is preparing for gate 25, you can share this workshop link. It is there in the description of this session, so that they can appear for this free workshop. You can download the app. The link is there in the description. On the app, you will have MMC, you will have workshops, you will have free sessions going on. Okay. So my dear, the conclusion is rank of a row matrix or column matrix can be either 0 or 1. Then my dear, we are also going to have one question like this. We are having a row matrix 1 cross 3, a column matrix. So we are having one row matrix and one column matrix. This is 1 cross 3, this is 3 cross 1. So obviously AB matrix is possible. So we are asking what will be the rank of AB matrix. Can you tell me? We are going for good questions as well. Can you tell me what will be the rank for AB matrix? Can you tell me guys what will be the rank for AB matrix? Please tell me that. Can you tell me the rank of AB matrix? First of all, when you will find out the AB matrix, you need to see what will be the order of that. Okay, so Vinay is saying 1 and Satyabrata Das is saying 3. So I would like to tell you, my dear, as you are having 1 cross 3 and 3 cross 1. So my dear, when you will be multiplying this, you know that this is the number of column, number of rows. They are equal, so multiplication is possible. So when you will multiply, this matrix will be 1 cross 1. So when this matrix is 1 cross 1, my dear, then the rank of AB is going to be 1 if this element is non-zero. And if it is going to be 0, if this element is going to be 0. So likewise, like we have seen row and column matrix, their product will become 1 cross 1. So my dear, that is why the rank can be either 1 or 0. Mind this thing. Everybody got it? Yes, Prakash Khan, Satyabrata. I feel everybody got it. This is the beautiful point I want to tell you. These all are the properties of a rank of matrix. And there are many questions asked in the previous question from the properties. Okay. So this is one of the property. So my dear, if you have this 1, 0, 1, 1, 0, minus 1. This time, can you tell me rank of AB will be what? Can you tell me rank of AB will be what for this question? Prakash Khan, that I will tell you, don't worry. Actually, in the principal stresses, when we study, there is application. In every branch, application is there for eigenvalues and eigenvector. But right now, I am not discussing that. Right now, rank of the matrix is going on. When I will teach you the eigenvalue, eigenvector, then I will show you why principal stresses are nothing but the eigenvalues of the matrix, stress matrix, and eigenvectors are nothing but the principal planes. That is mechanical civil application. I will tell you with respect to other branches as well. So the rank for this is going to be 0. The reason is, my dear, you know, this is a 1 cross 3 matrix. This is 3 cross 1 matrix. So when you will be finding out the matrix AB, multiplication is possible. And when you will say 1 into 1, 0 into 0, minus 1 into minus 1. So 1 plus 0 minus 1. This element is coming out to be 0. So my dear, as order is 1 cross 1, only one square sub matrix is possible. That is also 0. So my dear, that's why the rank of AB will be 0. Okay, so that is the point. Once again, we have the conclusion. And that conclusion is, when row matrix is multiplied with column matrix, provided multiplication exists, row of AB is either 1 or 0. Clear for everyone? So if the element which will be coming, if it is non-zero, the rank is 1. If it is 0, the rank is 0. Okay. So guys, moving further now, this is the identity matrix. Can you tell me what will be the rank of this identity matrix? If this is the identity matrix, can you tell me the rank of this? Okay, it is already I2. Can you tell me the rank of I2? Can you tell me the rank of I2? Yes. Aspace, Satyabrata, Vinay, Prakash. So Prashant is saying 1, Prakash is saying 2, Aspace is saying 2, Satyabrata is saying 1. So my dear, when you want to see that, first of all, you need to find out the order. This is 2 cross 2. It is a square matrix. So the very first square submatrix which is possible is of order 2 cross 2. It is 1, 0, 0, 1. You will find out its determinant. It is coming out to be 1, which is not 0. So it means the rank is 2. And you know, every time identity matrix is a square matrix and its determinant is 1. So that is why anytime, this is the property, if you have rank of identity matrix whose order is n, this is always going to be what? Going to be what? It is going to be n. So always remember, the rank of identity matrix is equals to its order. Clear for everyone? This is the property of rank of a matrix. Okay, so these are the properties I am deriving. I will show you all of them together as well. So don't worry about that. So guys, this is a 3 cross 3. What you will say? What you will say about this? What is the rank of this? Rank of I3. We are having good questions, guys. These are the properties I am giving you with the help of questions. Because you guys said, sir, try to teach us in the form of questions. That will be better for us. Yes, very good, very good, very good. So dear, this is a 3 cross 3 matrix. So my dear, if you see the order 3 cross 3, the very first square submatrix will be 3 cross 3. So if you will be finding out determinant of this, it will be coming out to be 1, which is not 0. So my dear, the rank is going to be 3. I already told you, whatever is the order of identity matrix, same is the rank of that matrix. Very good, Saurabh, very good Vinay, very good Satyabrata, very good Ashray. So we are moving to this matrix. This is said to be scalar matrix. This is said to be scalar matrix. Scalar matrix is a matrix for which diagonal elements are equals to k and all other elements are 0. So this is a scalar matrix. Can you tell me what would be the rank of A? Can you tell me what would be the rank of A? What would be the rank of A? Yes, guys. What would be the rank of A? Yes, 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 yes. Wonderful, guys. So guys, do like and share the session. If you see, this is once again a 3 cross 3 matrix. So the maximum order of square submatrix is 3 cross 3. So when you will be taking the determinant 2, 0, 0, 0, 2, 0, 0, 0, 2. So you know it will be coming like 8, non-zero. If it is non-zero, the rank is nothing but 3. So my dear, once again, I would like a point here. If you have a scalar matrix, then also its order is going to be its rank. Okay. Order of it is going to be rank. The types of matrix I already taught you in the first session of matrix. Okay. So my dear, the conclusion is rank of identity matrix is n. Rank of scalar matrix is n. So these are the conclusion. Now my dear, we have seen how rank can be calculated with hit and trial method. So whatever we were doing till now was hit and trial method. in the exam it can be very hectic if we get 4 cross 4 matrix or 4 cross 3 matrix or 5 cross 4 matrix. So it is going to be very hectic. So that is why, my dear, to find out the rank, there is a method given that is said to be row Euclidean form. Row Euclidean form is a method by using which we can find out rank very easily just by applying some elementary row operations. I will show you what we need to do in such cases. So my dear, first I am telling you the steps what we need to do. Okay. So whatever the matrix you would be given, first of all, if any row is there which is having all the elements as 0, this should be at the last. And as you are going from first row to the last row, the number of zeros before first non-zero element should always be in increasing order. And if you are going to make your matrix in that format, then my dear, this format is said to be row Euclidean form. And if it is in row Euclidean form, then the number of non-zero rows is the number of rank of matrix. Number of non-zero means if any row is having one element non-zero, we call it as non-zero row. If you understood this, it's great. If you did not know, no worries, because you will be understanding from the questions. So just see, like I am having this matrix. First of all, you need to check whether it is in row Euclidean form or not. So you see, is there any row which is 0, 0, all elements 0? Yes, it is. It is at the last row. Yes, it is correct. Then when you are going from top to bottom, the number of zeros are increasing or not? Yes, they are increasing. The number of zeros before first non-zero element. Here the first non-zero element is 2. So here it is 1, 0, here it is 2, 0. So number of zeros are increasing. So my dear, yes, this is in row Euclidean form. If it is in row Euclidean form, you tell me how many non-zero rows are there? This row is non-zero. So we will call the rank of this matrix is 1. Clear for everyone? Yes, you can say, guys. Today Abhinav sir have taken a wonderful marathon session on the soil. Then he have taken app class. Now also he is there on Sunday. So you can see teachers are always there to motivate you guys. Right now sir is there. So make heart sign for sir. So guys, this is the first question. If you see this second case, is there any row with all the elements 0? Is there any row with all the elements 0? There is no. So my dear, if there is no row with the all elements 0, then you will check when you are going from top to bottom, the number of zeros are increasing or not. Yes, here number of 0 before first non-zero is 1. Here number of 0 before first non-zero is 2. So yes, it is in row Euclidean form. So if it is in row Euclidean form, how many non-zero rows are there? How many non-zero rows are there? Prakash, classes are going on every Sunday. Okay, every Sunday the class is going on at 10 or 10:30 p.m. generally. Okay, so we have already seen probability, we have already seen matrix session, and after matrix we will start differential equation. Okay, so my dear, if you see this, the rank will be 3 because there are 3 non-zero rows. Okay, so my dear, now we are going to have this. Tell me, is this row Euclidean form? If you see, is there any row with all the 0 element? No, there is no. Very good, Vinay, very good, Prakash. That's great. You have answered it correctly. So my dear, now we are reaching to the next question. If you see this, now you tell me, is this in row Euclidean form? Is this in row Euclidean form? Is this in row Euclidean form? Please tell me that. Is this in row Euclidean form? Please tell me that. Vinay, Satyabrata, you got it or not? Here the rank will be 3 because there are 3 rows. Okay. Fine. If you see this, this is not in row Euclidean form. Why? Because my dear, first of all, there is no row with all 0. That's fine. That can be the case. But if you see here, the number of zeros are 3. Here the number of zeros are 3. So number of zeros are not increasing as we are going from top to bottom. So it is not in row Euclidean form. So when it is not in row Euclidean form, we will be making it in row Euclidean form by doing some elementary row operation. Like here you can operate R3 operating R3 minus 2 times of R2. So when you will make this operation on that, the first row will remain 0, 1, 2, 3. Second row will remain 0, 0, 0, 1. And third row will become 0, 0, 0, 0. Now it is in row Euclidean form. And now you can see there are two rows which are non-zero rows. So you would be saying the rank of this matrix is 2. So first of all, we need to convert it into row echelon form to check the rank. Clear for everyone? I feel now you got it. I feel now you got it. I feel now you got it. Okay. So you understood now, Satyabrata, how to do? You understood now, Satyabrata, how to do? Please tell me. So what we need to do, first of all, we need to see what is row echelon form. If there is any row with all the zero, that should be at the bottom. When you are going from top to bottom, the number of zero before first non-zero element should increase. And if it is not the case, you will be converting it into that by going for row, elementary row operations. And when you will be going for such operations, you would be reaching to the final answer that what are the number of rows which are non-zero. Then you will say the rank is going to be that number only. Okay, this is how we are going to do. Then my dear, if you will see the next matrix, is it there in row echelon form? Please tell me that. Is it in row echelon form? Is it in row echelon form? Is it in row echelon form? Tell me. As you are going from top to bottom, number of zeros are not increasing. And we have one row with all the zeros. So when you will be converting it into the row echelon form, first of all zeros should come here. When you will be going for multiple row operation, you will be having this 0, 0, 2, 1 and 0, 0, 0, 3. Now this is in row echelon form. This was not in row echelon form. So my dear, we have converted this in the row echelon form. Now you can see here number of zeros are 2, here number of zeros are 3, here number of zeros are 4. Can you tell me what will be the rank of this matrix? Can you tell me what will be the rank of this matrix? Yes. Prakash, Vinay, Satyabrata. Can you tell me the rank of this matrix? Yes, there are two non-zero rows, this and this. The rank will be 2. Yes, very good, very good, very good, very good, guys. Yes. Narsali Malam, very good. So we are having now the question. Now we are having 8 questions where we are going to convert it into row echelon form and tell the rank. Okay. After that, I will be showing you 18 properties of rank of a matrix. Okay. And my dear, one more class we will be having for matrix algebra where we will see the system of linear equations and eigenvalues and eigenvectors. With that, your matrix will be over. Sir, but in second case, first row only 1 0. In second case, first row. Arey bhai, I have told you na ki we will be going for row operation. First row operation will be changing this row with this one. Then you would be having this row at the top, this row at the bottom. And my dear, after that, this 0 0 0 3 which is coming at the top, it will be coming at the second number. When you have the rows like that, here 2 non-zero element, here 1 non-zero element. Even if 1 non-zero element is present, it is a non-zero row. Okay, Prakash? Even if 1 non-zero element is there, it is a non-zero row. So my dear, now we have this question in front of us. First of all, you need to tell me, is it in row echelon form or not? Is it in row echelon form or not? Don't worry, with the next 8 questions, you will have all the ideas. Examples I have taken in such a way that you will have an idea what to do for which type of case. So you tell me, is it in row echelon form? Is it in row echelon form? Is it in row echelon form? Yes. It is in row echelon form, yes, and you can see this is a non-zero row, non-zero row, non-zero row. So the rank of matrix A will be equals to 3. Very good, guys. Then my dear, we are moving to this question. Now I will be increasing the level of question. As you know, in these sessions, we start from 0 and becoming hero. Okay. So you have seen in the probability also, we started from very easy level and we went through the difficult most questions of the probability where we have seen conditional probability, Bayes theorem, all the cases. So my dear, if you have this matrix, now, first of all, this matrix is not in row echelon form. So I would be converting it into row echelon form. How? Yes, yes. What would be the answer? Great, great, Shore. Fine, fine, fine. R space is saying 2. So can you tell me, will you try this? Okay. So Prakash is saying 2, R2 brother 2, Vinay Joshi 2. Very good, guys. So when we are having this, you can see first of all, first and third row are same. So my dear, I will say R3 will be operating R3 minus R1. Okay. And also you can operate on R2. R2 minus R1. So when we are going for operating like that, you have 1, 1, 1. When you will be subtracting, this will become 0. When you will be subtracting, this will become minus 2, this will become 0. And this will become 0, 0, 0. Now, is it in row Euclidean form? Yes, it is in row Euclidean form. And how many non-zero rows are there? This row is non-zero, this row is non-zero. If any element is non-zero, it is a non-zero row. Number of zeros are increasing. Yes, here 1 0, here 3 0. So this is in row Euclidean form. Rank of this matrix is going to be 2. Very good, very good, very good, guys. So moving to the next question. 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 This is the third one. We have 5 more questions. Slowly, slowly, the level will increase. Tell me, is it in row Euclidean form? Not in row Euclidean form. Not in row Euclidean form. So we will be converting it into row Euclidean form. We will be converting it into row Euclidean form. You know, once again, some elementary row operations are required. Try to solve it and give the answer. Okay. Very good, very good, very good. So everybody is saying rank is 2. Let us see that. So I will be operating R3 as R3 minus 2 times of R1. And when I will be operating R3 as this, then you know it is the equivalent of the matrix. So it is 1, 1, 0, 0, 1, 0. So you would be having 2 times of 1, 0, 0, 0. Is it in row Euclidean form? Yes. Here all the elements are 0. Here we have 1, 0. So number of zeros are increasing. The rank of this matrix will be 2. Is it clear for everyone? Clear for everyone? Yes, yes, yes. So guys, moving to the next question. Moving to the next question. You understood R2 brother? Yes. Moving to the next question. Akash Kumar Yadav. Yes. So I would like to tell you this, the rank will be 2 here, not 1. Because now this one, you cannot make it 0. If you will try to make it 0, then this element will become non-zero. So this is already row Euclidean form. This is already row Euclidean form. So when it is already row Euclidean form, the rank will be the number of non-zero row. 1 plus 1. The answer is 2 for this. Moving further, guys, for this question. Question number 4. 4 more questions after this. Yes, Akash, Prakash, Shubhi. So this is the question, guys. First of all, you check that is it in row Euclidean form or not. And then after that, you can apply the operation to get the rank of this. Okay. So tell me what would be the rank for this question. What would be the rank for this question? Okay, Akash is saying 2. R space is saying 2. What about others? Tell me. Vinay. Okay, Prakash is saying 3. So my dear, first of all, if you will try to see this is, if you see, as you are going down, it is already in the row Euclidean form. It is already in the row Euclidean form. Still, if you will try to make them 0, you will not be able to make all these elements to be 0. You can try this. And that is why the rank of this matrix is going to be 3 only. Okay. The rank of this matrix is going to be 3 only. Because you cannot make any row completely 0. You can try it. Let us say you are saying that this and this row, I am going to add it. When you will be adding it now, this is, let us say you are operating R2 plus R1. Let us say you are doing this. So when you will be doing this R2 plus R1, this is 1, 2, 3. This minus 1 plus 1 will become 0. Then this 2 plus 2 will become 4. This will become 5. Then my dear, this is 0, 5, 6. Okay. You said, okay, sir. Now we can go for R3 operated R3 minus R2. When you will be going for that, you will be getting 1, 2, 3. Then you will be having 0, 4, 5. Then you will be having 0, 1, 2. Okay. So now it is not in row Euclidean form. When you will be trying to do that, you will be multiplying this with 4. You will be saying now R2 is operated R2 minus 4 times of R3. When you will be going for that, first row is going to be 1, 2, 3. 0, it is 0. 2 into 4 is 8, it is minus 3. Is it correct? 0, 1, 2. Then you will be going for the conversion of this row here, this row here. You will once again get 1, 2, 3. Then 0, 1, 2. Then 0, 0, minus 3. So you can see still it is, this is the row Euclidean form. Number of zeros are increasing, but the total number of non-zero row are 3 only. So rank of this matrix will be 3. Clear for everyone? Akash, Satyabrata, I feel you got it, everybody. So rank will be 3 for this case. Okay? Rank will be 3 for this case. So that's why I have shown you all the operations what are possible. Now slightly bigger matrix is coming. Sir, in checking could we... No, Prakash. In row Euclidean form, we go only for the row operations. Okay, in row Euclidean form, we are going only for the row operation. Okay, so here you need to find out the rank. This is question number 5. 3 more questions after that, then I will show you all the properties of rank. Okay, then eigenvalue, eigenvector and system of equation, we will be having one session in the next week and we will complete the matrix, and after that we will enter into the differential equation. So guys, you can see this. This is a 3 cross 4 matrix. Okay, so we have nothing to do with that. We will go for the row Euclidean form. So my dear, try to make it in the row Euclidean form. Try to make it in row Euclidean form. I want the answer from your side now. Okay, I want the answer from your side now. Okay, this question I have already calculated for you. So let us see how many of you give the right answer for this. Tell me guys. Tell me guys. Yes. This is 2, 3, 4, minus 1, 5, 2, 0, minus 1, minus 4, 5, 12, minus 1. I will give you one hint that you should try to make this as 1. If this will be 1, the things would be very easier for you. Okay? Yes. Very good. So R2 brother, Prakash, some are saying the rank is 2, some are saying the rank is 3. The answer is rank is 2. Yes. So rank for this will be coming out to be 2. Yes, Vinay, have you done it or not? So I am saying let us do operation on R3. R3 plus 2 times of R2. Okay, and I am doing 2 elementary operation together by doing R2 is operating as 2R2 minus 5R1. Okay, for saving the time, I am doing 2 operations together. First of all, this is 2, 3, 4 minus 1. Then we are having this, when I will be multiplying 2 times to this. 5 into 2 is 10. 10 minus 10 will be 0. So 2 into R2 will be 4. 4 minus 15 is minus 11. Then my dear, 0 into 2 is 0. Minus 20. Then minus 1 is minus 1. it is going to be minus 5. Minus 1 into 2 is minus 2. Minus 2 plus 5 plus 3. Then you would be having R3 is R3 plus 2R2. R3 plus 2R1. Sorry, not 2R2, 2R1. So when you will be having 2 to the 4. 4 minus 4 is 0. 3 to the 6. 6 plus 5 is 11. Then you are having 12 plus 8 is 20. Then you are having this minus 1 into 2 is minus 2. Minus 1 plus minus 2 is minus 3. So my dear, can you feel it? Can you feel it? This row and this row are equal? Yes. So I will say operating R3 plus R2. When you will do this, you would be getting 2, 3, 4 minus 1. You will get 0, minus 11, minus 20 plus 3. You would be getting 0, 0, 0, 0. So you can see now it is in row Euclidean form. Yes, it is in row Euclidean form. It is in row Euclidean form. And when it is in row Euclidean form, what would be the rank here? What would be the rank here? The rank of this matrix will be 2. The rank of the matrix will be 2. Wonderful, guys. Wonderful, wonderful, wonderful. So moving further to the question number 6. Moving further to the question number 6. 2 more questions after that, guys. Then I will show you all the properties together and then I will leave you. Just 2 more questions after this. Here, what would be the rank? Great, Prakash Khan. What would be the rank, guys, for this? You can also join my Telegram channel to get the handwritten notes of all the subjects. All the subjects means for maths also you will get. Okay. So this is the matrix. Try to solve it. So you just try to make this 1. This is already 1. So it is now very easy to make these 0 first of all. So you should try to make operate R2 minus R1. Operate R3 minus 5R1. So if this is 1, it is very easy to make this and this 0. First try to make this and this 0. After that try to make this 0. Okay. So in that way you will get the row Euclidean form. Tell me the rank. I have given you the idea to start with. So let us see how many of you give the right answer for this question. Prakash is saying rank is 3. What about you, Vinay? Yes, yes, yes. Try to answer it. Wonderful, guys. Wonderful, wonderful, wonderful. So, I am disclosing the answer. Waiting for 1 to 2 more students to answer. Yes, answer is 2. Sorry, 3. Answer is 3. Answer is 3. So my dear, when you will be operating R2 minus R1, 1 minus 1, 3, 6. So it will become 0. You are saying R2 minus R1. So it will be 9. 3, it is going to be minus 3, minus 3, minus 6. Minus 4, minus 6, minus 10. And when you are going to do minus 5R1, 0. Plus 5, then 3 into 5 is 15, 3 minus 15, minus 12. Then my dear, if you see this, 6 into 5 is 30, 11 minus 30 is minus 19. Then my dear, after this, this is not in row Euclidean form right now. Now you should try to make this as 0. So you can see what I can do. What I can do for that. What I can do for that. If you will be having this, is it 9 now? This is 5 times of R1. It is 5 times of R1. It is, I have written it wrong, I feel so. 5 R1 will be 5 minus 5. Then 8 minus plus 5. It's 13, I feel. Here I have done it wrong or correct. Is it 9? Tell me, I have done it correct or wrong? 9 minus 6 minus 10, is it correct? Is it correct? Yes. 8 minus 1. Okay. 8 R2 minus R1. 8 plus 1, 9 is correct only. Then you have minus 3 is minus 6. Minus 4 minus 6 is minus 10 is correct. Then I have done it 5 R1. It is 0. 5 minus 5. 3 minus of minus 5 is 8. 3 into 5, 15 minus 15. 3 minus 15 is minus 12. Then we are having this 6 into 5 is 30. 11 minus 30 will be minus 19. That is also correct, I feel so. 5, 6 are 30. 30, 11 minus 30 is minus 19. That is correct only. So now my dear, okay, that is correct. That is correct. Now my dear, you are going to make this as 0. And for that, you can operate it like कि I would be having R3. R3 minus, so I am operating on R3. So R3 I am multiplying with 9. 9 R3 minus 8 R2. When you will be going with this, what you will be getting? Here 1, minus 1, 3 and 6. When you would be having this 0, 9, minus 6, minus 10. So 9 R3 minus 8 R2. 0 will remain 0. 72 minus 72 will become 0. Now when you will be multiplying this with 9, subtracting like that, this will be non-zero, this will be non-zero. So it will become row Euclidean form. And once you will get the row Euclidean form, you can see that here there are 1, 0, 2, 0, and this is non-zero, this is non-zero. So the rank of this matrix will be 3. So is it clear? I am not writing these numbers, okay, because that is a calculation you can do. If you want me to do, I can do it. This is 8 times of 6 is 48. 12 into 9 is 108. You will be getting somewhere 60, that is coming out to be minus 60. If you will do for this as well, actually I have done it for you, it will be minus 91. Clear for everyone? The rank will be 3 for this matrix. So moving further guys to the question number 7, this is a 3 cross 4 matrix now. So when you will be having this 1, 3, 4, 3, 3, 9, 12, 3, 1, 3, 4, 1. So this is the matrix. Will you try this second last question from my side? After that, only one more question. Yes, Prakash, R2, Deepak, Vinay. Try to solve this. R space is saying 1. Okay, R space is saying 1. What about others? I am waiting for others to answer as well. Akash is also saying 1. Okay, so if you see this, first of all, 1, 3, 4, 3, 1, 3, 4, 1. And my dear, when you are going to operate R3 minus R1, and you are operating R2 minus 3 R3, you would be getting 1, 3, 4, 3. 3 minus 3 is 0, 9 minus 9 is 0, 12 minus 12 is 0, and 3 minus, this is 3 into 3 is 9. 3 minus 9 is minus 6. And when you will be subtracting this 1 minus 1, 0, 3 minus 3, 0, 4 minus 4, 0, 1 minus of 3 will be minus 2. So my dear, if you see this, it is not in row Euclidean form still. So you can say R3 operating R3 minus of R2 by 3. When you will be going for this operation, this is 1, 3, 4, 3. 0, 0, 0, minus 6. 0, 0, 0, 0. This is in row Euclidean form. Last row is 0. When you are going down, the number of zeros are increasing, and you can see there are 2 non-zero rows. So answer for this is going to be 2. So you guys have given nice and correct answer. Very good. R2, Prakash, Akash, R space, the answer is correct. Deepak, very good. So guys, this is about the rank of matrix. This is the 7th question. Now my dear, can I give you this question as homework? or will you do here only? You can do here also. Find out the rank of this. This is the last question for this session. Then in the next 5 minutes, 10 minutes, I will show you all the properties, what we have already discussed in small, you can say slide format for a good revision. Then we will close this session, and next week we are meeting for eigenvalues, vectors and system of linear equations. We have already taken 2 sessions on matrices and determinants, inverse of a matrix, adjoint of a matrix, cofactor matrix, minus, all these things are taught to you. Solve this question. I am giving you hint here. You can see 1 plus 2 plus 3 is 6. Okay, so this was the hint from my side. Solve this question. Solve this question. This is a matrix which is 4 cross 4. So you need to find out the rank. Try to convert it into row Euclidean form. Try to convert it into row Euclidean form. Yes, everybody. R4 very good. Rank is 3. So when you would be operating like that, 1 2 3 0, 2 4 3 2, 3 2 1 3, 3 to 5 plus 1 0, 4 to 6 plus 4 0, 3 3 6 and 7 0, 3 to 5 0. This is one row is becoming totally 0. Now my dear, you would be going for R3. R3 is going to be R3 minus 3R1. Then R2 will be R2 minus 2R1. When you will be going for that operation, what you will be getting? 1, 2, 3 and 0. When you will be going for R2 minus 2R1, 2 minus 2 is 0. 4 minus 4 is 0. 3 minus of 3, it is going to be 3 minus of what? 6. So it is minus 3. It is going to be 2. Then here 3 minus 3 will be 0. Then you are going to have R3 minus 3R1. Na? So 2 into 3 is 6 minus 4. Then 1, this is going to be 3 minus 3. 3 minus 3, 9. Okay, it is going to be minus 8. And then it is going to be 3. 0, 0, 0, 0. Now my dear, you just need to replace the rows and you would be getting 1, 2, 3, 0. Then 0, minus 4, minus 8, 3. 0, 0, minus 3, 2. And 0, 0, 0, 0. So my dear, rank of this matrix will be 3. Rank of this matrix will be 3. Is it clear? Yes. Thanks guys for your wonderful response. So we have completed the question. Now I am showing you in next 5 minutes all the properties and then I will leave the session. So guys, we have already seen that elementary operation do not change the rank of a matrix. We have already seen that rank of a null matrix is not defined or 0. Rank of n cross n identity matrix is n. Rank of n cross n scalar matrix is n. Rank of aij m cross n, it will be minimum of m and n, or it will be lesser than that. So if it is a 3 cross 4 matrix, the rank will be always less than 3. then rank of n cross n, non-singular matrix will be n. Non-singular means whose determinant is not 0. So if there is a 3 cross 3 matrix and that determinant of that order is not 0, then obviously that will be the rank itself. Then my dear, if A is a n cross n non-singular matrix, then rank of A is equal to rank of A inverse. It is also equals to rank of adjoint of A. Okay, so this is one more property. So rank of A and rank of A inverse would be same if it is a non-singular matrix. Next point is rank of row matrix is 0 or 1, column matrix is 0 or 1. Product of row and column matrix is going to be 0 or 1 once again. And if you are going to have addition of two matrices A and B, then my dear, rank of A plus B would be always less than rank of A plus rank of B. Similarly, rank of A minus B will be rank of A minus rank of B. Then rank of AB will always be less than equals to minimum of rank of A and rank of B. Then rank of AB will be more than rank of A plus rank of B minus n, where n is the order. Okay. Then my dear, we are going to have this. When all the elements of this matrix are same, can you tell me what would be the rank? When all the elements of the matrix are same, can you tell me what would be the rank? All the elements are equal. You would be operating the operations. You will be saying R3 minus R1 0. Then R2 minus R1 0. Rank would always be 1. Then if in a matrix all the rows or all the columns are proportional, then also the rank is 1. Why? Like you can do the operation R2 minus 2R1, R3 minus 3R1. So once again you will get the rank is 1. Okay. So these are the properties, and the last property is if the rank of A is n, then rank of adjoint of A is n. If rank of A is n minus 1, where n is the order of the matrix. If the rank of A is n minus 1, then rank of adjoint of A is 1. If rank of A is n minus 2, then the rank of adjoint of A will be 0. This is a star mark property. In the next class, we will see some questions on that as well. So we have completed, guys, with this. थोड़ा हिंदी भी यूज कीजिए अभिषेक तिवारी. डियर, एक्चुअली देयर आर सम स्टूडेंट्स हु डू नॉट अंडरस्टैंड हिंदी. दैट्स व्हाई इंग्लिश में लेने का कारण है ताकि सबको समझ में आ जाए. ठीक है, द स्टूडेंट्स फ्रॉम डिफरेंट पार्ट ऑफ द कंट्री, यू नो, एवरीबडी डू नॉट अंडरस्टैंड हिंदी. सॉरी फॉर द इनकन्वीनियंस. ओके सर, हाउ मेनी फॉर्म्स आर देयर फॉर एलिमेंट्री ऑपरेशन? Prakash, actually for elementary operation I have already taken last two session where I have given some shortcut to find out the inverse also. Okay, is it clear? Hi to brother, thanks for your love and support. So now my dear, this is the time to stop the session, and we will be meeting next week again, and I will be starting from here only. Okay. And if you see in the last class, we have taken a shortcut on inverse of matrix. That also you can check. And in the next class, we will see the system of linear equation from where question is coming. And also I will tell you the physical significance of eigenvalues and eigenvector. मैथ्स तो आपने बहुत बार पढ़ा होगा, आइगन वैल्यूज वेक्टर निकाले भी होंगे, पर उसका मतलब क्या होता है ये नहीं सुना होगा. तो यू आर गोइंग टू लर्न द मीनिंग ऑफ दैट एज वेल. ओके, so we will meet again next week, next weekend, Saturday or Sunday. Okay, so you can join the Telegram channel to get the notes as well as the practice problems. So goodbye guys for this session. Thanks for joining. Yes, Bala Sai, you can get the material from my Telegram channel, Mechanical by Dheeraj Sardana. There I shared. Okay. Yes. Okay guys.